Okay, good morning class. You're on to our grade 8 mathematics experience, the normal experience, and today we'll be looking at algebra in the matter of algebraic expressions and try to go a little deeper into our understanding of expanding or the removal of what? Brackets. In one or two of our previous videos we had tried to tease the concept of this, but today we'll go into deeper explanation and understanding of this matter. Our textbooks of reference will be Essential Mathematics for GSS 2, and also we have the New General Mathematics for GSS 2, which is our grade 8. Okay, so straight away we will start by teasing something a little easy for us to do, and then we will try to move on to handle something a lot more complex. Okay, right away we're going to removing brackets approach, or may say different approach to how we remove brackets. Now, you discover that the approach we're going to use now will look more arithmetic, but it's just to help us understand what we want to pass across. So let's look at idea number 1. So for idea number 1, if I'm going to solve this problem, I could choose to take care of the bracket first, which is something you're very conversant with from your elementary or your elementary mathematics or your arithmetic. So this will be what? 8. 3 minus 1 will be what? 2. So that will be 8 times 2. The bracket means 8 multiplied by whatever you get from this bracket. And obviously my answer will be what? 16. Now that's approach number 1. So let's look at idea number 2. For idea number 2, we could take 8 into 3 minus 1 to mean open on the bracket. This 8 will multiply this first, and this minus, this 8 will multiply the 1. So from your knowledge of board maths, I'll just write that on the board just to keep us in track. You discover that I will have to do multiplication before I do subtraction. So this will be 24 minus what? 8. And that will give me what? 16. The importance of what we've done on the board is to help you understand one simple fact, that whichever approach you're taking, you should arrive at the same answer. Whether you're taking care of the bracket first or you are expanding, you're going to get the same answer. But in practice, as interesting as these approaches might be, you can only use one. So you need to know when to use a particular type, and that is what this exercise will try to teach us. So we go into more algebraic framework now. Okay, so we have 3 questions on the board to try to drive home this concept. You discover that in solving this, we'll be using idea number 2 all the way. This idea is very good when you're dealing with arithmetic, but when you're dealing with algebra, especially when the terms are different, it's best to go with this idea. So let's look at this. This will be equal to what? 3a plus, these 2 will multiply a, and we also multiply 2b. So now I'm not going to be, I won't take that long route of writing them out. I would expect you to do some of these things mentally now. 2 times a number times a letter gives us what is called a number letter. So that will be 2a. A number times a number letter will give us a number letter. So what that means is that the only extra work you need to do now is to multiply this 2 with this 2. And that will give us what? 4. So that will be plus 4b. Now, how does this connect to previous knowledge? Collection of what? Like terms. I can see apples here, and I can see just banana here. So I'll add up my apples, and I'm going to get what? 3 apples plus 2 apples will give me 5. So I deceive my imagination and I write what? 5a plus what? 4b. And that concludes the solution to that problem. Now, when it comes to this one, remember we said that whenever we have a negative, we are careful to remember that our uncles and our aunties have visited. and they just know how to spoil things. So this will now be equal to 12x negative. We deal with the signs. Now, the order in solving is this. It is sign, number, letter. You want to write that somewhere? It is sign, number, letter. So maybe I'll write that more legibly. Sign, number, letter. And this idea comes alive when you're dealing with negative. So if I have a negative times a positive, I know I must have a negative out. The next thing I look at the number. Number times number letter. That will be 2 times 4. That will give me what? 8x. Now, I have negative 2 times positive 5 or times 5. Remember that negative times positive is what? Negative. So that will be negative. Then number times number will give me number. That will be what? 10. The final thing I want to do is to collect like terms. This is 12 what? X. Minus 8x. Change it to anything you want to. 12 popcorns, pack of popcorns plus minus 8 pack of what? Popcorns. That will give me 4. Good. So the technique here is to deceive your imagination. What does that mean? Try to work with things that will encourage your mind and not to discourage your mind. There are certain things you hear and you'll be like, oh. When students hear letters, they are, but if you mention apple, orange, discover that naturally they are coming out to you because in their mind, their minds can relate with that. Now this will be equal to what? 3. Negative times positive will give me what? Negative. Then I am concerned with the numbers. 7 times 5. That will give me what? 35. Negative times negative is what? Positive. Having taken care of the sign, the next thing I want to do is to multiply the numbers. And that will give me what? 28 and then x. Number times number letter. And that will give me what? 3. Now, 3 minus 35 will give me what? So what I will do is this. 35, I know is bigger than 3. But I have to remove 35 from 3. That means my answer must be negative. So I come to somewhere in my book, I just say 35 minus 3. And that's what? 32. That's what it should be normally. But because I have a bigger number taken from a smaller number, my answer will be what? Negative 32 plus 28x. There's something we call rearranging. You can rearrange it back. I want to see positive first, so I can write what? 28x and then minus 32. We are just rearranging. We're not dealing with equations. For expressions, you can rearrange and the signs will still be the same. Alright, so that takes care of that problem, and then we'll move into some more questions to test the concept we're trying to drive home. Okay, so we have yet more practice work to do, and as usual, we're going to try to expand this. Now, we have a number multiplying a number letter. So this multiplies this will give me 2 times 5, that will be 10x. This times this will give me plus 18y. Is that 18 or 16? Sorry about that. That should be 16y plus this multiplying this will give me what? 6x. Please let's watch carefully. Number times number letter to multiply the numbers and then x minus 3y. Sign, then the number, and then the letter. At this point, we can do what is called collecting of like terms. We can do what? Collect like terms. But I try as much as possible to stretch my students a little more. Now, rather than collecting like terms, do the collection mentally. Do the collection mentally. How do you do that? 10x plus 6x will give me what? 16x. And then 16y minus 3y will give me what? 13y. So 16y minus 3y will give me 13y. And that closes this one out. Now maybe for purpose of emphasis, while solving this, I'm going to break it down and collect like terms just to help us understand the matter better. Alright, let's look at this. This will give us x. X times x means x is multiplied twice. That will be x squared. Here again, this is something to call, we call indices. Indices tells us or gives us an idea of how many times a particular number is being what? Multiplied. So if I multiply x with x, I'm going to get twice that number as it were, as in an x squared. Not 2 times the number as it were, x squared. X multiplied twice minus x times 2 will give me 2x. A letter times a number will give me what? A number letter. Plus 3 times x, a number times a letter will give me what? A number letter again. And 3 times 2, which will give me what? 6. At this point, what are we going to have? We're going to have x squared. X squared is a different term now. I can play with this, so I'm going to rearrange this. I'll write plus before I write minus. So that will be plus 3x minus 2x plus what? 6. What does this give me? This will give me x squared. I can do some manipulation here, and that will be plus x and what? Plus 6. So that's what our answer is going to be for this one. So take note of what has happened here. What has been teased? If you multiply same letters, you have a square. Same letters, you have what? A square. So if I have a times a, for instance, a times a will give me what? A squared. B times b will give me b multiplied twice. So a squared means a multiplied twice. B squared means b multiplied twice. Is that clear? It's different from what we're talking about a coefficient. A coefficient teases the idea of how many times a number is being added. I think I said this in one of my previous videos. A coefficient gives us an idea of how many times a number is being added, and as such, if I have this, it will be what? 2a. A coefficient is always written in front of the number, so it's usually called, it's written in front of the letter, so it's more or less a number letter. But for index, if I multiply 2 same letters, I'm going to get a multiplied twice, which is a index 2, or a raised to the power of what? 2. So that's, I think that should be enough explanation for that idea. So let's come to this one. A times a will give me what? A squared. A times 2, letter times number will give me what? A number letter. Irrespective of what you're doing, irrespective of how you're multiplying that, the outcome will still be a number letter. So that will be plus 2a. Now, this is negative. It means that the content here will all change. The content here will all change. So negative 9 times a will be what? Negative 9a. And then negative here times positive here will give me what? Negative. And then 9 times 2 will give me what? 18. So this will give me a squared. I have no problem with a squared, but I do have an issue with this. I have 2a, I'm having 2 naira, and I have to give out 9 naira. How much more do I need? It's like, say what? 9 minus 2, and that will give me what? 7. So 9 minus 2 is 7, but that 7 means what I need. So that will be minus 7a and minus what? 18. So that takes care of this one. Now when we come to this, a times a will give me what? A term we already used to a squared. What about if we now have a times b? They are both letters. When we multiply both letters, correct, a, b, that's correct. What is happening here is this. We resort to use what is called the order of the letters of the English alphabet. Come again. The order of the letters of the English alphabet, which means that A will come before B. So that will be what? Plus AB. Now, this is negative. This is positive, this is positive. I expect my outcomes to be what? Negative. So this will be negative. and then I multiply b times a. B times a is still ab, because we always write our answers in the order of the letters of the English alphabet. So this will be what? A, B also. Now, b times b, this will be negative also, and then b times b will be what? B squared. B squared, good. So that will be b squared. So you discover that this is a unique item. This is another unique item. This is what I need to play with. I put a swing there to tell me there's something wrong with this and I have to do what? Deal with it. So this will give me a squared. AB minus AB is 0. It's like saying, look at this, AB minus AB. Using the concept of deceiving our imagination, I imagine this to be what? An egg. And this is another egg. If I have one egg and I take it away, do I have anything left? No. So that will be 0. So I don't have any business with this, so I won't write anything concerning that anymore. And that will be what? Minus what? B squared. And this becomes the answer we're expected to get.